The PA system shown in this video is used by one of Australia's leading bands, the Hunters and Collectors. The band's bass player, John Archer, has been a major force in putting together the system we are about to examine. He has even designed and built some of the parts himself. John kindly brought the Hunters and Collectors PA into Ausmusic and shows us in great detail how to set up and operate a band PA system.
Hi, I'm John Archer from the Hunters and Collectors group, and today we're going to set up a PA, and hopefully I'll be able to show you some of the boring technical details that are actually involved in such an operation. The very first thing, having got the gear, this is the gear we're using today, into the venue you're going to play in, the first thing that usually goes up is the PA stack. For safety, a stack of boxes is usually huggered together. If you look at this box on the ground, you'll see there's a hugger, which is basically just seatbelt material, underneath one of the boxes. Once we've stacked them all up on top of each other, we'll tighten the hugger up, and then it should be one fairly safe, solid object. This is just a small stack, just for demonstration purposes really. It's about 8 feet high. It consists of two types of boxes. The bottom two are sub boxes, the top two are mid boxes. They look the same, but the drivers are different. The drivers are optimised for the frequency range that they're operating in. Normally, you wouldn't stack in a venue mid boxes or horn boxes, high frequency boxes, below about head height. You'll see there's a mid box starting about 4 feet. In a solid crowd of people, that'd be made virtually redundant by the crowd of people. So 6 feet, subs above that, mids, horns is the usual way it works. So you may, in many venues, you end up with a stack many feet, 14, even 16 feet high. You'll notice that the horns are splayed at an angle away from each other. Each horn is a 60-degree horn, covers about 60-degree width. So if you splay them apart a little bit, you still get the combined coverage between these two of about 90 degrees, a bit less than the 260s. They cover about 40 degrees vertically, so you can imagine in a room, it's pretty important that they are angled down in a standard room. In a bigger outdoor venue or a very large room, that's often less critical. In today's setup, we're setting up in a room that's not ordinarily a venue. If you have a look around it, you'll see it's a lot wider than it is long, the way we're setting up, with the stage over by the Deborah Conway sign. So in a more normal venue, the room would be longer than it is wide. We wouldn't set the stacks up as we have here, angled in towards the stage as much. But as a general rule, you would angle them in a small amount unless it's an extremely wide or outdoor situation, in which case you may have the stacks pointed straight ahead. We're now at the top of the stack. We're looking from behind the horns. This is the hugger in my left hand. What I tend to do is pass it through the handle of the next horn to you, and then you can pull it tight, and when the whole thing is huggered together, even though it won't look it from the front of the stack, it'll be quite secure. The last part of huggering the PA together is just tightening the hugger, pulling it through without twisting it, hopefully. To get it really tight, if you put it over your shoulder and using your knees, you can lift that way and make the hugger as tight as possible. Then gather it together and behind itself so it's out of the way. Okay, we've set up a front of house stack. Having done that, we need amplifiers to drive it. This is a standard amplifier rack for driving monitor speakers. It's 3 power amps, they're stereo power amps. They're also biamps, which means the left-hand side of each amp drives bass. The right-hand side of each amp drives higher frequencies, horn drivers. Over on my right is a wedge speaker box. at the top is the horn, driven by the right-hand channel of the biamp. Here's a 15-inch JBL driver, driven by the left-hand side of the power amp. So this rack, coming back to the rack, 3 biamps, it can drive 3 separate mixers, be they wedges or side fill or drum fill. So for an 8-send monitor setup, we need 3 of these racks. The 9th amp is to drive a Q monitor, which is a wedge or a pair of wedges that the monitor operator has so that he or she can tell what they're doing, hopefully above the noise of the band. At the back of the power amp rack, you can see how the more basic connections are made. First of all, you need 240 volt power into the rack. There are outputs on the back of the rack to slave to other racks or desks or effects racks or anything else you need to drive except for lights. The inputs are 3-pin XLR inputs. These are an industry standard. They're not like RCA jacks that you commonly find in a stereo, because they have 3 connectors. 1 is earth, 2 is minus or plus, and 3 is plus or minus, depending on whether you're using the American or the European standard. This is an enormous source of confusion in the PA world. There is no consistency at all in terms of which pin is hot. These connectors here are 4-pin EP connectors. They are the output from each of the biamps. There are 2 output plugs from each amp, so you could easily run 2 wedges off 1 amp. You'll notice there are 4 pins. 2 pins for the bass driver, 2 pins for the horn driver. You're looking at a close-up of 2 XLR or Canon connectors. They're 3-pin connectors. The one on your left, this one, is a male connector. The one on your right, this one, is a female connector. These connectors are at either end of a microphone lead. The reason that these are used, apart from having plus and minus lines on the connectors, which enables the cancellation of any noise that's picked up along the line, is that although the 3 pins on the male connector are the same length, the sockets in the female connector are not the same length. And when you connect these 2 together, like this, pin 1, the earth connector, connects first, and then the signal leads connect afterwards. What this means is you don't get an enormous bang when you plug the things in. This is very important in a professional system. They also lock. This is extremely important. If you look at a standard microphone, you'll see that it also has a Canon connector on the back of the microphone. This simplifies connection in the PA. Having male and female connectors is important because it makes it harder to plug an input into an output. That's, to get it wrong. We've just looked at a biamp rack. This is a front of house amp rack. In the industry, there's a lot less consensus about a standard way of driving front of house speakers. Different combinations of amplifiers are used in different ways with different types of connectors. There's virtually no standard. The best I can do is show you one example, this being it. In this setup, there is one side of the top amp is for high frequencies for horn drivers. It being a Yamaha PC2002, it can drive 4 high frequency horns, which are normally 16 ohms, quite easily. The left-hand side of the top amp and both sides of the second amp are all mid amplifiers, so we can drive 3 by 315 mid boxes. The bottom 2 amps, which are although a lower height amp, they are deeper and they do have more power transistors in them than the Yamaha amps above them, gives us 4 channels of sub amplification, so we can drive 4 sub boxes, 3 mid boxes, and typically 3 horn boxes on each side of the front of house PA system that we've got here today. That's the front of the amp rack. If I turn the amplifier rack around, which isn't easy because it weighs about 140 kilos, on the back you can see the connections that are made to the amp rack. At the top, the input. Next, all of the speaker outputs. These two, for example, are EP connectors, like on the monitor rack that we saw before. They come out of here, go into a simple loom to the top of the PA stack and into the two horns at the top of the stack. Moving back down to the amp, there are 5 3-pin XLR type connectors that also go to a loom that will drive up to 5 bass or mid boxes. Today we've only got 2 subs and 2 mids, so you can see each box has a 3-pin XLR connector in the back. There are also more EP connectors here that can drive additional horns and additional sub boxes, up to the maximum of 4 subs, 3 mids and 3 or 4 horns. Okay, we've plugged the front of house amps into the front of house stack. It's probably good to have a general understanding of how microphones and DIs are connected to the front of house desk and to the monitor desk. Here we've got a standard Shure microphone on a boom stand with a mic lead plugged in. The microphones and DIs on the stage are all connected into this box, the stage box. In this case it has 27 inputs and 27 splits. That is, for example, in channel 1 there is also an output of that same channel just beside it, all the way through to channel 27. So supposing this one went into channel 1, then this part of the multi-core, you can see the whole thing coiled up here. It doesn't look that long, it's actually 65 metres long, and it goes to 27 outputs which are plugged into the front of house desk. So it's like 27 mic leads, 65 metres long, all bundled together. To get to the monitor desk, we need another multi-core cable. This one is only 24 channel because the desk is only 24 channel. We've got 27 outputs here, so we plug the 24 channels that we most need in the monitor system into those 27 outputs. This is a shorter multi-core. It goes across here to the monitor desk. Here we have 24 connectors that will go into the 24 channel inputs on the monitor desk. Each of the connectors is labelled with a number corresponding to the channel that it. We've now plugged from the stage box into the monitor desk. I've powered the desk up just so I can describe a few of the features of the desk to you. We'll show you how that's done in a little while. This is a 24 channel into 8 group monitor mixing desk. It's not for front of house. It has no faders on any of the channels. It would be quite difficult to mix front of house using this desk. But for monitors, it's ideal. Each channel is arranged as a vertical module. The input is near the top of the channel and the output's near the bottom, so it's fairly logical in terms of seeing how each channel works. The first 2 buttons at the top
One of them is on the left. It is a phase change, and what that does, you'll remember before we talked about there being two standards for microphones, the European and the American standard, and it switches between those two, between pin 2 hot and pin 3 hot. Below that, the first knob, is the gain control. On this desk, it's labelled from -20 to -60. Now, that's a bit of a mislabeling really, because that's not how much gain the knob is applying. What it is indicating is the sort of levels in decibels that this would be a suitable setting for. So if, for example, the signal from the microphone was around the -20 dB level, which is pretty typical for a vocal mic on most instrument mics, then this would be a suitable setting. If it was a much quieter instrument, or perhaps a passive DI that might need considerably more gain, some DIs need around -50 setting. In other words, they're putting out -50, you need to add 50 to get them up to about 0 dB or unity gain. Some devices, some DIs, put out considerably more than -20. In order to accommodate this, there's a switch up here called a pad. It's a 20 dB switch which pads down the input level so that -20 setting will be suitable. 20 minus 20 equals 0. So with this switch we can accommodate signals from 0 dB in, which is about line level, all the way down to -60 dB in with the pad out. If at any stage we have too much gain, this peak light here will light, which I might be able to demonstrate. 1, 2, there. You may have just seen it, I'll do it again. 1, 2, so that was way too much gain. The next section of the channel is the EQ section. It's like the tone controls on a hi-fi amp, at least in the sense that the high and the low controls are like bass and treble. There's also a mid-frequency control. The frequency that the mid-frequency control operates at can be swept from about 350 Hz, or 0.35 of a K, around to 5 K. So from low mid through to high mid. The high frequency control operates at around 10 kHz on this desk, which is quite high sibilance. The low control operates at 100 Hz, which is fairly low bass. You can normally, if you've got good ears, you might be able to hear from 20 Hz to 20 kHz. I sort of doubt that I can, but I've been playing bass for too long. The next controls are auxiliary 1 and 2. These are auxiliary sends, as they say. They can be used to send to echo units or reverb units, or when you're short of sends, to a 9th or a 10th monitor mix. We don't often use them, we don't often need them. They're just versatile auxiliary sends. When you do send to a reverb unit, and we do have one at the top of the graphic rack here, this is an SPX90 Mark II, which is a multi-effect unit. It can do reverb, delay, a multitude of effects. When we send from this channel to that effect unit, we then return it into the auxiliary return inputs, auxiliary 1 and 2 in. If we turn those on, bring them up to unity gain, and then assign with these push buttons which groups we want them to go to, supposing we wanted them to go to group 1 and 2, the left return to 1, the right return to 2, we would push those buttons in. I'll turn them off. The next 8 knobs are really the most important part of the mixing desk. These are the sends to the 8 groups. So if I want to send to group 1 from channel 24, I'd turn up this knob here, turn the channel on with the switch at the bottom, turn the group on with this master on switch. 1, 2. We now find over here on the group master 1 VU meter, you can see a deflection corresponding to what I'm doing, what I'm saying. To provide even finer control over the sound of the wedges or the side fill or the drum monitor, we have the graphics rack, which you saw briefly before. That was the effect unit that we happen to have at the top, but then we have 8 1/3 octave graphics. The reason that we need graphic equalizers is that, despite what manufacturers will tell you, loudspeakers do not have a flat frequency response. That is, they will be louder at some frequencies than others. Another factor is that rooms also do not have a flat frequency response. They will resonate at some frequencies. Depending on how much carpet or other damping material around, they will absorb high frequencies more than others. And a third factor is the microphone itself. It as well does not have a flat frequency response. So there are 3 things that you're trying to compensate for to try and provide an overall smooth response from the system. And the 3rd octave graphic equalizer is probably the easiest way to do it. What it has are faders that operate, in this case, at frequencies from 40 through to 16,000 hertz in 1/3 octave intervals. Some graphics will have half octave or 2/3 octave or full octave intervals, and therefore less control over the sound than a 3rd octave graphic. As you can see, we have it set up at the moment. This was set up for a wedge. No, it wasn't. It was set up for a side fill mix at the Central Club. We needed to put a fair bit of very low bass in. We needed to cut some low mid frequencies out, around 125, around 400 hertz, and around 1 kilohertz. These were all frequencies that were tending to feed. Also around 4, 5, 6K, there was a danger of feeding. At very high frequencies, it was okay to push them without feeding. This also added some clarity to the sound. So for each of the 8 mixes, if we're using 8 mixes, we have to equalise them to try and provide as smooth and as natural and as listenable a sound as we can achieve. Before we go much further, we're going to have to plug in to 3-phase power. The reason we use 3-phase power is because of its ability to supply much more current than you can get out of a standard 240 volt outlet. You can normally get 10 amps out of a standard 240 outlet, which is 2.4 kVA. Each amp rack draws about that, and we're going to run about 5 amp racks, so it's not suitable. We have to use 3-phase power. Most venues have a 32 amp 3-phase outlet, at least one, hopefully 2. When they say it's 32 amps, it's 32 amps per phase, so it's a total of 96 amps. If you look at the connectors here, there's a male and a female connector on a typical 3-phase lead, a bit like the mic cable. The 5 pins are the active for the 3 phases, a common neutral, and a common earth, total of 5 pins. Once you take this to a distribution board, you can then split it out into 3 separate 240 volt outlets of a more standard type. I'll show you that in a minute. When we plug 3-phase in, we plug it in, we connect it at both ends so that it's safe, and then we turn it on. We don't turn it on first. So a 3-phase plug goes in like that. You have to push it fairly hard, and then it also has a screw locking device, which you should use. Then we go and plug the other end in, and I'll come back once that's done and switch the power on. This is the other end of the three-phase cable. This is the distribution board. Now plug the two three-phase connectors together, and again there's a screw lock to hold the two three-phase connectors together for safety. On the distribution board there are 3 pairs of standard GPOs. In theory that's 40 amps per row, although we're only sending 32 amps to it. You hardly ever pull the full 10 amps at any one time out of all of these sockets. So 32 in, 40 out is usually considered safe. It's fused anyway, so if you did pull more than 32, you'd blow a fuse here in the distribution board. Okay, it's connected at the other end. We can turn the power on. Okay, we've plugged the three-phase power in, we've turned it on. It seems to be operating. The fluorescent indicators here indicate it's working fine. The first equipment that we've actually plugged in are the monitor amp racks. These are the backs of the 3 monitor amp racks as described before across here. The simplest way to do it is to daisy chain the power for the 3 amp racks together. So we're coming out of one outlet here into the first amp rack, using its output across to the second amp rack, from its output across to the third amp rack. Then we're taking this power lead up to a power board in the back of the graphics rack, which you've seen the other side of, and from there a power lead is coming out of that and going into the monitor desk. So the entire monitor system is now powered up. You remember the group output faders. The actual outputs are XLR connectors from 1 to 8 across here, and a 9th one that's been put in. It's not a standard connector with the unit. I had to put it in myself for the Q out. So we have effectively 9 mic leads then running to the amp racks, going 1, 2, 3, 4, 5, 6, and 7, 8, 9 into those amp racks. You'll probably realise there's no connection yet for the graphics. With this desk, the easiest way to connect the graphics is what's called an insert point. What that uses is a stereo jack. A stereo jack is like a guitar jack, except that it has a tip, a ring, and a sleeve. What that means is that it's possible for us to connect any one of the graphics as an insert into the desk, just like that. At the other end of this tip, ring, and sleeve lead, there are 2 standard tip and sleeve jack connectors going in and out of each of the graphics. So plug into each of the master insert points. Once we've done all of these insert points, the only thing that remains is to connect the actual speaker leads from the EP outputs of the amp racks into the wedges, the side fill, and the drum fill. Today, we won't actually have to use all 8 groups and all 9 power amps, because the band that's going to be playing with the gear doesn't have that many people in it. It'll need near and far side fill, drum monitor, and 2 wedge sends. That's 5 sends, so we'll have 3 spare. So now I'll plug in the EP connectors to the wedges and side fill and drum monitors. Next, we're plugging one of the wedges in using an EP lead. This is an EP lead. As you can see, each of the connectors has 4 pins. Both ends are female ends. It doesn't matter which way around you connect this lead. So I can plug one end of it into an amp rack, and then I can run the lead hopefully around the outside edge of the stage so people won't be walking over it. And then it connects into the side of the monitor. We've already connected into this wedge on your left-hand side. Then wedges are often run in pairs with exactly the same signal in both of them on either side of a person listening to them. After all, your ears are on either side. It's better than listening up your nose, which is what would happen if you had a wedge straight in front of you. This is a short EP lead. Because this wedge has an EP connector on either side, I can daisy chain the two wedges together, point them in more towards each other, and then they'll be pointed roughly at the microphone that'll be on the end of this stand. What we've got here is a 315 box, similar or the same as the sub boxes used in the front of house system, and a horn driver. The two of them together make a drum monitor or a side fill monitor. Each of the 15-inch drivers you can see here handles 600 watts continuous or 2400 watts peak. So the three of them together, 1800 watts continuous or 7200 watts peak. There are hardly any amplifiers that can deliver that much power, so it's pretty hard to blow them up. So if I spin the speaker box around, I can show you how it's plugged in. I've got an EP lead here from the amp racks, goes into the horn, and then using a 3-pin to 3-pin XLR lead, I can power the sub from the horn by looping off it. Remember that in the EP lead, it carries both the high and the low frequency parts of the signal. High frequency for the horn, low frequency for the sub, from the amp racks, which are over there.